of positions in the military, civil, and industry sectors. Starting in the Air Force as a U.S. test pilot, Pam later joined the NASA Astronaut Corps, piloting 2 space shuttle flights and commanded a third, logging over 1,000 hours in space. I'm looking at her, she has held key positions in Lockheed Martin, the FAA, and DARPA before her confirmation as Deputy Administrator. We really are lucky to have such an accomplished aviator, trailblazing role model, and visionary leader. And please join me in giving a very warm welcome to Deputy Administrator Pam Melroy.
We've changed and evolved so much community. We're preparing to responsibly explore the solar system. We're returning samples from asteroids. Commercial entities are landing on the moon and preparing to build new destinations in orbit around the Earth. We're gaining new insights into the universe and our place in it, and rewriting the textbooks in the process.
And lift off.
The world around us may be captivated by the wonders of space, but there's a truth we can't ignore: the fragility of our cosmic domain.
Today, we face a pivotal moment. The time to act is now.
NASA is unveiling a strategy to make a difference in the world.
While the breathtaking complexity of the space environment makes it challenging to know what we should do to protect the cosmos around us, NASA will leverage our incredible scientific and technological strengths to lay out a space sustainability framework that is data and results driven. Together, we can ensure the stars remain within reach for generations to come. Good morning. Thank you, General Pringle, and thank you also to the Space Foundation for another fabulous year. This is so amazing to be here together. I am just really astonished when I look at how far we've come over the last 39 years. This conference has grown incredibly. I also want to say thank you. One of the big changes that I've seen is that we have a lot more of our international partners here, and so I'm very grateful to all of you who traveled today to be with us, and I'm very grateful to those of you in the audience because there's a Delta IV Heavy launch going on at the same time. And I don't know how I feel about that, but I am very grateful for your presence here today, and we'll all watch the video afterwards and enjoy that. So I just want to talk about the community for a moment. As we, have 39 years of the Space Symposium, just looking back at the changes in our community, we're really doing stuff that was completely unthinkable 39 years ago, like bringing samples back from asteroids. We have commercial entities landing on the moon and preparing to build new destinations in low Earth orbit. We are absolutely astounded at the images that are coming back from the James Webb Space Telescope, but also our Earth observing missions such as SWAT and PACE. Having said that, there are a few things that are actually the same 39 years later. First of all, the incredible awe we feel about the business that we are in and the things that we do every day, but also the fact of the matter is that space is really hard. It is still very, very hard. We know it. It's very challenging to operate in this incredibly harsh environment. So many challenges that push us to the limits of human ingenuity and our technology. Harsh vacuum of space, extreme temperatures, cosmic radiation, you bet. The idea of building infrastructure hundreds or thousands or maybe even millions of miles away is mind-boggling, and the complexities of the missions that we're doing now really demand a very high level of meticulous planning and execution. And we're not always successful, as we know. Every time we go beyond the Earth's atmosphere, it's really a triumph, and let's never forget that. It's a testament to humanity. So the question is, if it's so doggone hard, what are we doing it for? Well, I think we do know why we're doing it. It's really about going out into the cosmos. As staggeringly difficult as space brings incredible benefits to humanity, unique benefits that we can only achieve in space. So first of all, overcoming the hurdles of space travel that I talked about leads to advancements and developments in science and technology that benefit humanity in multiple other ways. We promote interdisciplinary collaboration. We have creative problem solving. Those things benefit all of us in a variety of ways. And the pursuit of exploration also generates incredible scientific discoveries. I mentioned in the video that we're upending the textbooks. Asteroids, early cosmology, it's happening right in front of us. The things that I, as an astronomy and physics student in college and graduate school, couldn't even imagine some of the things that we're learning. So this is great, not just because it satisfies some innate curiosity in humans to learn about the universe, but we're actually able to put our own place biologically and also the Earth in its place throughout the development of the solar system and the universe. And that benefits us to understand our place in the universe. Also, space is a catalyst for global cooperation. As I mentioned, so many of our international partners are here, but it also inspires future generations to go into STEM disciplines so we can keep that virtuous cycle going. By uniting nations together, as we all share a boundary with space, things like the International Space Station, Artemis, and the Moon to Mars program, we're fostering a sense of unity in humanity and mutual respect that goes far beyond other earthly considerations. So the bottom line is, yes, it is totally worth it. The difficulty of getting out there and doing these things is absolutely worth the benefits to humanity. We see it, and others see it too. It seems like every day there's a new entrant around the world, whether it's a company or a nation, that wants to tap into the rewards of space exploration. As such, the aerospace ecosystem is rapidly changing. We have a lot of these new entrants and people doing exciting things. We're seeing new commercial capabilities, increased satellite activity in low Earth orbit, novel space capabilities such as satellite constellations that connect people anywhere on Earth. Hard to imagine. Autonomous spacecraft doing activities once only possible with crew aboard, and of course, commercial space destinations. In 2023, over 200 launches occurred globally, sending over 2,500 satellites into space, and over 90% of them have commercial operators. Hey, space may be hard, but there's a lot of people who see the benefits in it, and that's bringing a lot of new actors to the table. So here's the challenge. With all these new entrants, all this new activity, all these new capabilities, we're making it actually harder on ourselves by not having a comprehensive framework that we can all share and understand for how to keep the environment sustainable for future activities as well. Not just the things we're doing today, but make sure that space is sustainable and available for all of us in the future. So if we want to keep growing, and I think we do, the time is now to organize ourselves to ensure that we can continue to preserve that outer space environment for generations to come. So a story for you. A few weeks ago, we experienced a near collision of two satellites. So I know you're thinking, yeah, I know, happens all the time. Satellites pass kilometers away from each other. We worry about it. We hope it's going to be okay. Let me tell you what, this time was really different. It was very shocking personally, and also for all of us at NASA. On February 28th at 1:30 in the morning, a NASA spacecraft called Timed and a Russian satellite, neither of them maneuverable, were expected to make a close pass to one another, not kilometers apart. We recently learned through analysis that the pass ended up being less than 10 meters apart, within the hard body parameters of both satellites. Less than the distance of me to the front row. Had the two satellites collided, we would have seen significant debris generation. Tiny shards traveling tens of thousands of miles an hour, waiting to puncture a hole in another spacecraft, potentially putting human lives at risk. Right now, there are about 11,800 spacecraft around the Earth, but only 9,800 are operational. And that means 18,000 debris objects that are at least 10 centimeters in size cruising around our planet, along with more than 100 million others that are a diameter of a millimeter or more. It's kind of sobering to think something that's like the size of the, eraser on your pencil could wreak such havoc on our beautiful and amazing space ecosystem that we're building together, but it can. Hey, we're all worried about this. We've been talking about this for a while. We've all been really, really concerned. So I'm not really telling you anything new about that, although the timed spacecraft really scared us all. So here's the question. If we're all so worried about this, why haven't we done anything about it? And I think we have done some things. I go back about 2 decades, the common sense measures from the orbital debris standard mitigation practices, which NASA helped spearhead 2 decades ago. Really good, solid, common sense practices based on passivating upper stages, doing things that we could all understand was going to make a difference. And the UN has actually taken some steps forward with additional guidelines for space sustainability. But the reality is, all this great stuff we're doing, all these new entrants and new capabilities and new technologies have made the world a very complex place. So I'll share personally, as a technologist and as a leader, I've really been uncertain. I've been very uncertain about what steps are actually going to have the biggest impact. Analyses often seem to me to be limited to a single parameter, or maybe 2. And the individual actions often rely on adjacent capabilities that we don't have, like really precise situational awareness of small debris. I just am feeling like we're at a place where common sense and intuition isn't going to cut it anymore. We're going to have to take a step forward. We're going to have to recognize those common sense measures were good for a simpler environment 2 decades ago, but we're going to have to step forward and embrace the complexity. I have to tell you, through the years, when I was at DARPA, when I've been at NASA, I've heard a lot of ideas, and some of them from you out there. But I was actually kind of left unconvinced that we actually knew what was going to happen if we took a specific action, particularly when I compared them in this rapidly changing environment to other actions that people are equally advocating for. How do we measure them and compare them against each other? Which is going to have the greatest impact? So this is where NASA comes in. As a science and technology organization, we can help, and we need to. Today, I am convinced that what the NASA team has put together is the right move. So today, NASA is releasing Volume 1 of an integrated space sustainability strategy. So I'll tell you about the steps that brought us here. Last year, we commissioned a cross-agency advisory board for tackling this issue. We have a whole swath of groups working in different organizations at NASA, tackling various pieces and aspects of this monumental problem, from research to operations and beyond. But just as the environment is more complex, we really can't afford to be stovepiped at NASA anymore in our approach. We needed to take an integrated approach. So we stood up the safety and mission assurance community, the chief engineer, the Office of Technology Policy and Strategy, the Science Mission Directorate, Space Technology Mission Directorate, and Space Operations Directorate. Each one of these offices and directorates have some connectivity to the problem of space sustainability and orbital debris, whether it's conducting spaceflight missions, developing technology, analysis to prevent collisions, to characterizing the debris environment and the space weather that affects the debris environment, and supporting mitigation. So under this Space Environmental Sustainability Advisory Board, we tasked this group to tackle the problem and develop a whole of agency, cross-agency strategy to leverage our mission as a science and technology organization to address what we thought the biggest challenges were. I want to give extra special thanks to Travis Blake of the Science Mission Directorate and Tom Colvin from the Office of Technology Policy and Strategy for co-chairing this strategy development. I will tell you I'm really proud of the work that they did. A good strategy is simple, elegant, and almost obvious. And it doesn't come easy. It takes a lot of work, and they did a phenomenal job. So the first question, though, that they really needed to tackle is an articulation of the problem, a key part of a diagnosis that goes into building any strategy. What about this is so hard? Why is this so hard? Why have we struggled to make the right steps in this area? And how can we approach this and embrace the complexity going forward? And what NASA, as a science and technology leader, can do about it. And we didn't neglect our own house. We also asked, hey, what can we do better in our own space operations and the things that we're doing? So I did mention this is volume 1. There's a realization that space sustainability covers a vast swath. So in order to scope it properly, volume 1 is where things are most critical, Earth orbit. But we recognize that a part of space sustainability is also here on Earth, it's also in cislunar operations, and it's in deep space. We know that we are going to have to tackle each one of these domains in a future volume of our space sustainability strategy. And we commit to releasing those strategies. The next one that we're going to work on is the effect of our activities in cislunar space, because that feels very urgent right now as well. The others will come later. So I will briefly unpack the 6 goals and update you on the progress that we've made for each of these goals since developing this strategy. First, and I think most foundationally and most critically, we need to converge on a widely accepted framework for assessing space sustainability. So we have different organizations, different people working with different lenses, different models. We can't even all agree on how many pieces of debris are in orbit because we all have so many models out there. We have different ways of approaching the problem, whether it's space sustainability, debris remediation, reentry survivability, the actual risks that come from debris, space weather, and let's not forget the economic drivers. The Office of Technology Policy and Strategy recently released a very interesting paper about the cost effectiveness of debris remediation. And it's a very, very interesting paper. It's just a new lens. It's one of many lenses, but we've got to incorporate them together. So by collaborating with domestic and international stakeholders, we aim to establish a shared framework and a shared perspective, which will enable us to create a consistent set of parameters and metrics that we can all agree on. And then we can use that framework to understand the effect of not just turning one knob, but turning multiple knobs at once. And it's going to be a huge challenge to knit all these different models and frameworks that exist together. But it's going to enable us to pinpoint the critical uncertainties that drive risk. And that's our second goal. We're going to tackle what those critical uncertainties are and how they drive this framework and our models. We aim to minimize those uncertainties and focus specifically on the ones that have the largest impact. And we want to seek breakthrough improvements to sense and predict the space environment, explore new operational approaches, and identify cost-effective methods to limit debris creation, and then also prioritize approaches for managing existing debris risks. So this is going to drive new technology developments. Goal 1 is the framework, Goal 2 is critical uncertainties, Goal 3 is about the technology investments. That's the part everybody jumps to first. We think it comes third, actually. It's going to leverage insights from Goals 1 and 2 to create an investment portfolio focused on advancing the technologies and capabilities that are crucial, as well as the capabilities that we need to be more sustainable at NASA. operationally. We're going to really focus hard on a transition plan. We are a science and technology organization. That means the science and technology that we develop around this has to be proliferated. We have to have transition partners, and we're eagerly looking for them. Investments will target early-stage orbital debris management, enhanced space situational awareness, traffic coordination, and environmental understanding, as well as all those critical uncertainties that we've identified from our framework. It's really critical to facilitate technology demonstrations, which I'm sure is the part everybody wants to jump to. But again, we have to have clear goals in mind, make sure that we're making the right investments, and have transition partners, because we're aiming to benefit the whole space community, not just NASA. So these 3 goals alone are pretty good. I'm pretty proud of those first 3 goals. I think the next step, though, is recognizing there's a policy aspect to that, and I hope the framework is going to help us with that as well, not just the science and technology piece. The framework will also help us look at changes in policy and how they will make a difference in the environment, particularly harmonized with technology investments. And so we're obligated, it's very important to look to the policy piece of it. I'm happy to say that we've updated our very own internal NASA debris remediation policy, because we had some constraints on funding technology development that we'd like to loosen up a little bit. And although NASA is not a regulatory agency, we work very closely with our regulatory partners, especially with all the commercial activity going on, and we're proud to leverage our science and technology capability to give the best advice and support that we can to regulatory agencies and other partners. This proactive approach is going to benefit both U.S. regulatory agencies, but it will also aid our international deliberations, particularly as we go forward trying to harmonize and coordinate our activities, especially on orbital debris mitigation, and we work closely with the State Department on that. So I mentioned our government partners and our international community, which brings us to Goal 5, coordinating a multilateral approach in response to this. And recognizing this, NASA aims to foster collaboration both domestically and with our international partners. We want to enhance information sharing with academia, industry, interagency, and international partners. So we're not doing too bad today. I want to say that. We've already started to address these goals. We have 43 lines of effort across 4 organizations, $18 million worth of work in the 24 budget. Safety and mission assurance, technology policy and strategy have already stood up a team to address Goal 1 and begin to work on the framework. And we've kicked off an effort to evaluate the widely used orbital debris mitigation standard practices given the dynamic new space environment. Now, a couple of things you might be interested in. We're very interested in making progress with the release of that strategy, and that's fine and good, but there's a lot more we can do inside the agency. I did mention we have 6 goals, and the 6th one was organizing NASA for the success of this effort. So not only are we coordinating our technology investments, we want to pull on all the activities that are happening inside NASA and not have our responsibilities be so spread out across organizations. It wouldn't be an integrated strategy if we didn't have an integrator. So we will be naming very shortly, putting out a position description and soliciting people to apply for a director of space sustainability at NASA who will have responsibility for integrating and executing on this strategy. So stay tuned. That's coming out very shortly. So let's see. Okay, here we go. QR code. That was what I was hoping was going to come up. It's a link to our new space sustainability strategy. What would a NASA talk be without a QR code? I'm very excited about it. I do want to say there are probably a few people in the audience who really wanted us to jump to that Goal 3 right away. They thought, darn, I was hoping for some big, fancy, exciting new technology. Well, I can promise you, once we've got a framework where we feel very, very confident of the impact that those changes can make, we're going to have some spectacular science and technology. And we got a little bit cooking on the back burner, so stay tuned for that. I said it before, and it's worth repeating, space is busy. I love watching rockets lift off. I'm sorry that we missed the heavy launch today, but I know we'll all look forward to this. We've been making it harder on ourselves, and NASA's really proud to take a step forward to try to make it easier for all of us to do the right thing. Thank you.